Friends, in today's question, a flat plane is moving normal to its plane through a gas under the action of constant force F. The gas is kept at a very low pressure. The speed of the plate is V is very much less than the average speed U of the gas molecules. Which of the following options are is or true? So this question is more of a theoretical type as compared to analytical, but somewhere we are going to use little bit of equations, and those equations will be more or less related with the momentum, change in momentum. Okay. So let us from there only, we can say momentum exchange between the gas molecules and the plate. Momentum exchange between gas molecules and plate. So the momentum is changed, we can say, as the now in the question there is the possibility that, let me draw the figure first. So this is the plate and these are the gas molecules, and these gas molecules will be at the leading edge as well as at the back end also. So therefore we are going to divide this question into two parts. This we are going to call it as a leading, and this we are going to call as a trailing. So this plate will be moving with the velocity of v, and the average velocity of these molecules is given as u. So let us start from the leading phase rather, and then we are going to solve it for same method using the trailing phase also. So the momentum exchange between the gas and molecules for leading phase. And it is given that the average speed of the gas molecules is u. The average speed of molecules is u. Therefore, with speed u, they are going to collide with the leading phase. So therefore, molecules collide with leading phase with u speed. And it is also given that the speed of plate V is very much less than the average speed of u. So we can say that since the plate is moving with the velocity, the plate is moving with velocity v, which is very much less than u. Therefore, the relative velocity of molecules with respect to plate. Therefore, the relative velocity of molecules with respect to plate will be approximately equal to u plus v. And for the simplistic reason, we assume that the collision is our elastic collision. So we say that when a gas molecule strike the plate, and rebounds elastically, the change in momentum let us call that a delta P leading, will be directly proportional to m u plus v. Therefore, this we found calculated for only one single gas molecule, and if we are having n number of gas molecule, then we can say that total change in momentum due to n molecules hitting the leading phase so we can write the equation that our leading phase, let me complete it, is proportional to flux of molecules nu, is proportional to flux of molecules, that is given as n multiplied by u, where n is the number of molecules and u is the average velocity of molecule. Therefore, we can write that F leading will be directly proportional to n u m u plus v. This was our leading phase. Similarly, we are going to do for the trailing phase. Momentum change for molecules hitting the trailing phase. Now in this case also, we are going to find out relative velocity, then their change in, you can say, delta P, and then the total force. Okay, let us start with the relative velocity. So we have relative velocity will be approximately equal to u minus v, and delta P trailing is directly proportional to mu minus v, and delta F, total force which we are going to call as F trailing, will be directly proportional to nu m u minus v. Now let us calculate the net force. So we can say net force, which we are going to call at F resistive, and this F resistive will be equal to F leading minus F trailing. F resistive is the resistive force on the plate. The resistive force on the plate, which we are going to call as F resistive. So we can say that our F resistive will be equal to F leading minus F trailing. Substitute the values. We get our F resistive. We can write this as NUM, we can take as common, and this becomes U plus V minus U minus V. And this comes as our NUM times V. 2 we can simply ignore it because it will be a constant part. Okay, there is no need to write 2. And so here we can say ignore 2 because it is coming as 2V, sorry. And it is also given that we have for V, which is very much less than U, because in this equation we have U as well as V, and we have to find out whether the F resistive is more dependent upon U or it is more dependent upon V. Okay. And we are given that V is very much less than U. Okay. So from here we can say that the relative velocity of the gas is dominated by U, because U is very much larger than as compared to V. But the resistive force, you can say, but the resistive force depends linearly on V. As the momentum transfer difference is proportional to V, as the momentum transfer difference is proportional to V. Is proportional to V. So therefore, we can write that our F resistive is directly proportional to V, and when our V is very much less than U, or we can say lower velocity regime. Lower velocity regime. Now we are going to use conservation momentum. Conservation of momentum, which says that rate of change of momentum will be equal to rate of momentum transfer from the gas. We can say rate of change of momentum, rate of change of momentum will be equal to rate of momentum transfer from the gas. Rate of momentum transfer from gas. Thus, we can write that when the F force, external force is applied, we can say the external force F provides a constant momentum input. Provides a constant momentum input. So we can write the equation that F will be equal to m dV by dt plus F resistive. And at steady state, dV by dt will be equal to 0. At steady state, dV by dt will be equal to 0, or we can say that the resistive force balances the applied force. Resistive force balances the applied force. That is, F resistive is equal to our F. And under this condition, if the velocity, we call it as a terminal velocity, therefore we can say that the V terminal, that is a terminal velocity, will be directly proportional to F. As the forces are in balance, the velocity will be now the terminal velocity. And the last part, we are supposed to find out the pressure difference between the two faces. Pressure difference between the phases. Phases mean pressure difference between leading and trailing phase. If we can say on leading phase, P leading will be directly proportional to N mu u plus v, and on trailing phase that is P trailing will be equal to N mu, and this is u minus v. Therefore, the pressure difference let us call that delta P will be equal to, or rather we can say proportional, not equal, P leading minus P trailing. We substitute the value and we get this as delta P is proportional to N mu multiplied by V. And here also we can just ignore the constant value. Therefore, we can summarize all the results into 3 points. Based on this, we can draw the answers also. Summarization first states that the resistive force F resistive is directly proportional to V. Resistive force, which we found as F resistive, is directly proportional to V. Second, terminal velocity is achieved. Terminal velocity is achieved when F is equal to F resistive and the third part is that the pressure difference is proportional to U multiplied by V. So therefore, we can say that, from the given option number A, because it is given that the F balance is resistive force, so this is true. The plate will continue to move with a constant non-zero acceleration at all times. This is false. The resistive force experienced by the plate is proportional to V. This is also true. And the last is the pressure difference between the leading and trailing phases of plate is proportional to UV. This is also true. So therefore, A, C, D are the correct options. You can see from here that options A, C and D are correct. So this question is complete, but it was more or less, you can say, theoretical approach with minor here and there some use of equation. So this completes the question. Thank you.